Hi friends, myself Majidip, studying in Sri Venkateswara College of Engineering, Bengaluru. So today my presentation is all about types of corrosion, which is a subtopic of corrosion and electrode system, which is module 3 from the subject applied chemistry for the CSC stream. So let's go into it. This was my introduction. Subject applied chemistry for CSC stream. Topic types of corrosion. So there are mainly two types of corrosion: differential metal corrosion or galvanic corrosion, or and differential aeration corrosion. And the differential aeration corrosion is again subdivided into two types: waterline corrosion and pitting corrosion. First, let us know what is corrosion and its definition. So corrosion is defined as a destruction of a metal or an alloy by the surrounding environment or electrochemical reaction. So this will lead to corrosion. So example of corrosion is rusting of iron. So now let us learn about what is differential metal corrosion. So differential metal corrosion, also called as galvanic corrosion, so occurs when two different metals or an alloys when they are in electrically contact will exposed to an electrolyte such as moisture. In this electrochemical process, one metal acts as anode and undergoes corrosion, whereas other metal acts as cathode and remains protected. So here it is metal which is acting as anode will undergo oxidation, and the metal which is acting as cathode will undergo reduction. So corrosion can be also be defined as the formation of large number of galvanic cells on the metal surface with cathode and anode. So major causes of galvanic corrosion are difference in the electrical potential of two metals in contact. So there is electrical. So there is an electrical part between the two metals, and fluids such as atmospheric humidity or salt fog exist that is able to break down the metal. So these are the major causes of galvanic corrosion. Uh, Metal with low electrode potential will act as anode, as said before, and the metal with high electrode potential will act as cathode. So the anode metal will undergo oxidation and get corroded, whereas a reducing reaction occurs at the cathode metal, and here no corrosion occurs. The reaction may be represented as follows. So at anode, oxidation takes place. So the metal, for example, take iron. So iron get oxidized to iron ions, and at the cathode, hydroxide ions are being formed. So the application of galvanic corrosions are piping and plumbing system, structural applications, automotive industry, marine environment, electrical connections. And how to minimize the galvanic corrosion? So selecting metals with similar electrochemical properties, using insulation between the similar metals, applying protective coatings, and proper design and material selection in engineering applications. So in the image, you can see that the bolt and washer are made up of different metal, and the nut has been made up of different metal. So the bolt and washer have been made up of metal which has low electrode potential than the nut. So the bolt and washer will undergo oxidation and thus get corroded, whereas the nut will undergo reduction and it is protected from corrosion. And these are the examples of galvanic corrosion or differential metal corrosion. Here, differential aeration corrosion. So it is defined as this corrosion happens when there is a variation in the availability of oxygen at different locations of the metal surface immersed in an electrolyte. So this difference in the oxygen leads to the localized corrosion. So what are the major causes of this corrosion? So stagnant or trapped electrolyte, surface irregulation, flow induced effect, oxygen depletion. So the metal in contact with less oxygen will act as anode, and the anode undergo. So whereas the metal in contact with more oxygen act as cathode, and the reduction takes place. So it has been protected from corrosion. So the reaction may be represented as follows: so that at anode, oxidation of the metal takes place, and at the cathode, a reduction of the metal takes place. So in oxidation, let's take an example of iron. So iron get oxidized to iron ions, whereas at the cathode, so oxide ions have been formed. So when these iron ions combined with these oxide ions, iron hydroxide has been formed. The if that is Fe OH twice. So when this Fe OH twice combined with the atmospheric oxygen and moisture, so hydrated iron oxide is being formed. So which is what is called as rust. So this type of corrosion occurs when two different parts of the same metal are exposed to different oxygen concentration. Example of iron rod when it dipped in water. So the part of the metal which is exposed to the less oxygen concentration will act as anode. So the part which is exposed to more oxygen concentration will act as cathode. So the anode regularly undergoes corrosion and the cathode region is unaffected. So this can be represented in the diagram as shown above. In differential aeration corrosion, there are two types as told earlier. So that is waterline corrosion and pitting corrosion. So now let us learn about waterline corrosion. So when an iron rod is partially dipped in water for a long time, so the inner portion of the iron rod below the water line is exposed to only to dissolved oxygen. Thus the portion below the water line above the water line is exposed to more oxygen. Thus, the portion below the water line act as anode and undergo corrosion. So the upper portion act as cathode and is unaffected. So distinct brown line is being formed just below the water line due to the deposition of the rust. As you can see in the image, iron rod dipped in water. So the surface of the iron inside the water is in less contact with the oxygen concentration, whereas the above the water surface iron strip is in more contact with oxygen. So the less oxygen concentration surface will act as anode and undergo corrosion, whereas the other part will act as cathode and the reduction will take place and it is unaffected from corrosion. So the reaction may be represented as follows: at anode, oxidation of the metal takes place, and at the cathode, reduction of oxygen will take place. Pitting corrosion. So it is one of differential radiation corrosion. So pitting corrosion is a localized corrosion of metal surface confined to a point that takes the form of cavities. So pitting corrosion is one of the most damaging form of corrosion. So pitting corrosion is usually found on passive metals and alloys such as aluminum alloys, stainless steel, and stainless alloys. So when the ultra thin passive film is chemically damaged, and does not immediately repassivate. So the resulting pitch can become wide and shallow or narrow and deep, which can rapidly damage the walls. So mainly in pitting corrosion, what it happens is when a dust particle or oil droplet get deposited on a surface, metal surface. So the surface below the dust particle or the oil is in less contact with oxygen concentration, whereas the other surface is in more contact with oxygen. So where metal surface which less oxygen concentration will act as anode and oxidation will take place and which leads to corrosion, whereas the other surface which is in contact with more oxygen level, so will act as cathode and reduction will take place and unaffected from corrosion. So in pitting corrosion, small pits are being formed in the area or the surface where dust or oil droplets have been deposited. So with this pitch can usually split throughout the metal surface when pitting corrosion occurs. So this is because it has a sufficient amount of electrons to be extracted from the cathode. These are the examples of pitting corrosion. As you can see, time passes, it spreads all across the metal surface as it has the ability to gain electrons from the cathode and undergo corrosion. So thank you for watching this video.